title of the project is Design Stage Assessment of Fan Inlet Distortion Response, Operability, and Aeromechanical Impacts. Project funded NSERC Alliance combined with MyTax Accelerate as well as industry. So the project's a collaboration with two companies, Pratt & Whitney Canada and TurboStream. Pratt & Whitney Canada is kind of the main partner. They're the ones contributing financial support to the project, as well as in-kind. TurboStream is just contributing in-kind. So they basically make a piece of software that we'll be using within the project, whereas the kind of customer, if you will, is Pratt & Whitney Canada. They're the sort of, the main driver for the project. The project is basically about trying to find ways to make it so that during the design process for the big fan that sits at the front of a jet engine, that it's possible to predict kind of the lower limit of the amount of flow going through that fan for which the flow will remain stable. So all compression systems, whether you're talking about a fan or a hair dryer or your vacuum cleaner, anything that involves some kind of compressor moving any kind of fluid, has, for a given rotational speed of the device, some lower limit at which a flow rate at which the flow cannot sort of be sustained. Basically, eventually the fact that you're trying to raise the pressure of the fluid is so challenging that the flow just says, I am not doing this, I give up, I am too lazy, and essentially the performance inside the blades in the machine starts to break down. In many applications, you get what's called a rotating stall. Rotating stall is where locally, maybe, if you can imagine, a fan might have somewhere between 10 and 20 blades all the way around. Maybe in a region of 2 to 4 blade passages wide, there'll be basically a blob of stagnant flow that isn't really moving through the machine anymore. And that actually rotates around, but it doesn't rotate around at the same speed the machine is moving. It rotates slower than that. And sometimes it can even rotate in the opposite direction than the machine is moving, but slower. And that significantly reduces how much flow will go through the machine as well as how much overall performance you get. And this is a big problem if this happens on a jet engine, because there's not much you can do to recover from it other than to shut the whole engine down and sort of start it back up again. So you don't really want to do that during, say, for example, takeoff. So to make sure that doesn't happen, engines fans for jet engines are currently designed with enough, they call stall margin. So basically the difference between the flow rate that's designed to go through the machine and the flow rate at which that flow will break down, with some kind of sufficient margin there to make sure that in any practical situation the engine will encounter, that stall won't happen. And they have to demonstrate this in certification testing for engines. So that's essentially the scope of the project. So it's a 3-year project